Hi everyone, welcome back. Thanks for doing that in-class assignment. For this video, we're going to be continuing our talk about safety and dive a little deeper into different slip type of errors. So if you recall, we broke up our errors into three different kinds, slips, lapses, and mistakes. And slips and lapses being more the execution errors, planning errors being more, or mistakes being more planning errors. Um, Within slips, we can break that down into further three categories there: capture, description, and mode. And we're going to walk through those in this video and talk about these different kinds of slips. So I'm going to use three examples, one about driving, one about using a faucet, and another one about driving as well. So hopefully these all work for you, but we are going to think about them in terms of capture error, description error, and mode error. Let's start with a capture error. A capture error is one that occurs when a person starts to do some action or sequence of actions and then sort of veers off into another direction. This again, slip is often a cognitive type of a thing where you start to do something like maybe try to drive to school, uh, or I'm sorry, let me fix that example. If you start to do something like, say, drive to the dentist, and then just kind of go into a pattern where you accidentally end up driving to school or home instead, those are sort of a capture error that we would describe it as. The second type of error is a description error, and these are ones that are sort of infuriating to me personally. It makes me sort of nuts, and is really related to UI design, and I'll explain that in a minute. But a description slip occurs when two actions are very similar, and so you make the mistake by accidentally substituting one for the other. So in UI design, consistency is a good thing for learnability, right? So if you have all the different tools you can use to edit all look pretty similar, that's a good thing to learn, like which tools are editing type tools, right? But it could be bad for safety, particularly if we could make a mistake where the differences between the two of them can actually have some pretty drastic outcomes. So we call this inadvertent similarity that can be an issue where we sort of make them close, but that closeness actually can be problematic. So these are the types of errors that we have when we sort of mistake one thing for another. I use the example of a faucet here because this happens to me all the time. The designers of a faucet are going to have a really similar looking handle for hot water and cold water, right? Now, stylistically, it's not cool to label them with a little H and a little C to make it clear which one does which one, right? People don't like to have that in their homes. They want their faucets to look cool for some reason. I don't know. But because that's the case, the two handles look identical, and so it's easy to make an accident between one or the other. So if you ever turned on the water thinking you were turning on the cold and it actually turned out to be hot and burned yourself, that is a description slip. We're actually supposed to know which side is which side, but I can never keep track of that. So that's why I use the faucet as an example for description slip. Let's talk about mode errors. And mode errors are states in which the same action has different meanings. And this is generally caused by failing to correctly evaluate the state of an interface when we talk about UI problems. The most classic one is caps lock. In fact, it's built into almost every UI now to recognize when caps lock is on. My other favorite that makes me totally crazy, it's better now, but when I was younger and not used to it, man, the insert key was like my enemy. And it's because when you put the UI, when you put the system into this different mode, your actions have different outcomes. So in caps lock, when you hit the A key, you now get a capital A instead of a short A, right? When you put the insert key on, when you type in a space in a word processor, normally it makes additional space in there, but when you have the insert mode on, it will actually crush those letters out, right? It'll write over the top of them. So both of these things can be problematic and create errors when the user doesn't understand that they're in this state. So to kind of cover overall the causes of slip and lapse errors, typically these are from inattention or inappropriate attention when your user is working on these things. And so we need to design in ways that help people who are being inattentive or would make inappropriate actions, we want to design ways in order to try to limit their ability to make mistakes even from inattention. And very commonly, there is a speed accuracy trade-off issue that goes in here. You can imagine which way people typically like to lean. But the speed accuracy trade-off is where there's this really complex relationship between, and I like how they phrase this, an individual's willingness to respond slowly and make relatively fewer errors compared to their willingness to respond quickly and make relatively more errors. This is described as the speed accuracy trade-off. So typically people in a UI opt for speed, which means it drops their accuracy. So it's our job to have to limit this, understanding they're often going to go too fast, and we need to help them limit the errors that come from going too fast. Now, one of the UI designs that's baffled me for a long, long time that really depicts this accuracy speed trade-off is Amazon's method of checkouts, which is just still terrifying to me, and I never used it. But here is a side-by-side example on the same UI of giving you the option to deliberately choose accuracy or speed. So if you are willing to slow down, you can be more accurate if you use the add to cart button here, because it'll walk you through the normal sort of online purchasing process. But if you're a maniac, or just somebody who wants to get this done quickly and not so worried about the errors and accuracy, you can go right to this buy now with one click button. Like, the power of that is amazing. But man, it's terrifying the number of errors that you might have. You have to remember, why do I have the right credit card in there, the right address, all these sort of things, where accuracy can be achieved by just slowing down and doing the traditional add to cart thing. So again, in design, we need to think about these things, that our users are going to be making these choices, and there's a willingness aspect here. Are they willing to slow down in order to reduce their errors? And or are they willing to speed up and deal with increased error issues? So that comes to the point where now we need to think about error prevention. Error prevention from capture and description errors is something where what we really want to do to help our users is to avoid habitual action sequences that have identical prefixes, okay, particularly in a command line type of an environment. So we can imagine some consequences where if we have the same starting prefix, you might have a memory lapse, right? A cognitive lapse where you type in the wrong thing that can have a pretty poor consequence. Another thing to think about is description errors need to be balanced with that consistency heuristic, so that when we're designing something, we want to have a UI that is internally consistent. It helps people learn how to use it. But what's going to happen is that different things should look and act differently, and similar things should look and act similarly, right? That's our sort of consistency heuristic. You want similar things to do the same thing, but it induces this problem. What if the similar things can have different and important consequences, which can be really problematic? Like the faucet, right? The description error. So a good example of this that I won't admit whether I've actually fallen prey to or not, I did, it was terrible, is that in Linux, if you type a command like this one, the sudo chmod -r 777 /. This gives permission to files in the directory. Basically, all users get all read-write edit access to all files in all directories, right? So this can be useful, although definitely not recommended, if you have a directory that you want to give access to any users that can get into the system, okay? So that can be really useful. But again, not recommended, but it can be really problematic if you do the almost exact same thing and not type in the dot. If you just do a slash here, the same exact command, so a very long identical prefix, right, with just one difference here, this gives permission to files in all directories. And it also turns out that it actually undermines the sudo function here. So the sudo, if you're not familiar with Linux, is a super user do, and that allows you to override a lot of the security things that might happen in Linux. And by giving these permissions, there's something that happens in the background that I'm not super fully aware exactly how it works. But essentially what it does is it strips the sudo of having the super user function. And now you're actually incapable of doing many things, including changing the file permissions on here. So essentially when you do this to a system, you mostly brick it. which sucks. I've been there. So you can see that, I mean, this one is sort of an extreme example, but you can see by having these sort of similarities, right? And even from a command line perspective, if you're trying to help me recall how these things work, right? That's a command line feature. It's really helpful to have this really similar thing to have permission to files be doing things, right? But in this case, it would be really wonderful if Linux had a very powerful safety feature in place that stops people from making this error, because it can be pretty catastrophic. You need to detect this sort of thing for your user. For mode errors, error prevention there is basically, well, the first line of defense is to really limit or eliminate the modes that you allow people to do. The more modes, the more ways of sort of having the same action create a different effect. The more times you do that, the more times you set your user up for not knowing they're in that state and making that mistake. For the modes that you do include there, you really need to increase the visibility of the mode. So that's why your caps lock button does have that little light on there, because it's such a crucial mode. We add that as like a hardware feature in order to reduce the errors on there. And the other thing that we can do is add what we call a spring-loaded or a temporary mode. For example, a shift key is a spring-loaded mode, where what we do is that mode is only enacted while you're physically engaging in a specific way, and as soon as you let it go, then you go back to the default mode. Same for temporary modes, where you can set the mode to only be there for a few minutes at a time, that kind of thing. Thanks for listening, and I will see you next time.